Thanks everyone for coming. I'm Dave. I'm one of the co-founders and CEO of Fictiv. Show of hands, how many people know what we do? Oh, sweet, I don't even have to describe it. How many people have used us before then? Okay, cool. So that's a good mix. At least you guys know about us, and if you haven't used us before, so Fictiv's a manufacturing platform. We help people produce physical parts in the early stages of product development. Today we're talking a little bit about 3D printing and CNC. We just launched CNC and added it to our platform, I guess about 2 weeks ago. So pretty exciting. We're now doing 3D printing in 24 hours and CNC machined parts in 3 days. So we're pretty excited about it. We have some awesome panelists that kind of help describe the stories, and we're going to talk a lot around how you think about prototyping, moving through different technologies, talk about material choices and some of those things. So I'll let these guys introduce themselves and maybe talk a little bit about what you guys are working on.
Yeah. Hi, I'm Abby. I work as a mechanical engineer at Momentum Machines. We're a really small startup. We do food automation robotics, so we're making a hamburger making robot right now.
Yum.
It's really fun. And I went to school with Dave, so that's how I got connected with this panel. And I'm here to talk about prototyping.
Cool.
Hi, my name is Rafi Isle, and I work at Highway 1, which is a hardware accelerator in San Francisco. I'm the senior designer there, so I work a lot with startups. We do 2 cohorts of teams twice a year, so 20 teams come through our program each year. And I spend a lot of time with them figuring out what to make and what material at what time, at what resolution, in order to answer what question. So a lot of challenging their assumptions through prototyping.
My name is Scott Stieber. I am the Director of Engineering at Radicand, which is a consulting firm 2 blocks that way here in Soma. We are a full stack product development firm, so we offer ME, EE, and ID services. Our client base is 100% hardware startups. We got started 3 years ago in another facility that's still open down in Redwood City that has kind of morphed into more of a co-working space for hardware startups. So both with our team here in San Francisco doing consulting work and the incubation and co-working space down in Redwood City, both facilities and the entire team is 100% dedicated to helping hardware startups figure out who are they designing for, what are they building, what is their product, and how do we take steps towards something that's ready for manufacture.
Awesome. Let's steal that back. Do we have 2 mics or we just have the one?
There's one right here.
Okay, cool. Then we don't have to pass back and forth. Awesome. Cool, so to kick it off, what we're going to do is just kind of open the floor up a little bit and ask some questions, and would love to get your guys' opinions. So something I think is very vague and not talked a lot about is what is and does a hardware development cycle look like? I think what's really interesting is, Abby, you're like boots on the ground, doing it every day. Rafi, you're helping like teams along 20 every year, and maybe easy or not, Scott, you have to like help guide people through it and help set expectations. So maybe Scott, starting with you, how do you think about hardware development cycle and some of those different stages with the companies you work with?
So what's interesting about our team and our consulting company is that we focus on helping hardware startups. So we are engaging with people in the very earliest phases of product development, literally taking something from whiteboard forward. So our process is very, very prototyping centric, and we view that as, we view it and we describe it as a risk mitigation method. So when a client comes to us and they have that whiteboard sketch or that napkin sketch, it's a hardware startup that represents 100% risk. It's 0% certainty about who you're designing for, what's the product, why. Every imaginable question is out on the table at that point. 100% risk, 0% certainty. So we use prototypes to kind of deconstruct what's an otherwise very daunting path forward in a very complex problem space involving multiple users, multiple parties. What's the problem definition? What's the product? We deconstruct that piece by piece into what we refer to at Radicand, what we preach and teach our clients. We deconstruct it as critical function prototypes or critical experience prototypes in some cases. So we break down what's in a very daunting, complex problem into bite-sized, very quick prototyping sprints. And this is something that happens in the space of a day or 3 days, a week or two max. And it's really a matter of taking that list of risks, the things we're concerned about, and how is something going to get to market and be successful, and piece by piece attacking those with prototypes, very targeted, and testing our assumptions and evaluating our ideas and kind of taking things one by one from that risk column over to we're certain here's how it's going to work, here's what it's going to look like, and here's why we're doing it. So it's a very strategic process that starts with those critical function prototypes. You do that week after week until you're suddenly ready to bring all of those together into what we refer to as a functional system prototype. So this is a term born out of ME310. Some guys in the room who've been to that class at Stanford. The CFPs roll into a functional system prototype. That's your first opportunity to bring all of these findings together and for the first time actually put all the features into a single prototype. There's tons of integration issues that'll pop up there, and that's when you're then kind of on the right path for the conventional EVT, DVT, PVT kind of development cycle that many of you guys are probably familiar with if you've been in a hardware company trying to launch a product. So we specialize in that early phase, getting you to EVT and onwards, and from there it's a very long road ahead to mass manufacture, but it all starts with those critical function prototypes.
Do you see something similar, Rafi? Did you guys teach a similar methodology?
Yeah, so we teach a similar methodology, except that our startups usually come with something closer to along lines of an MVP. So they have an idea that we hope has been tested with a large number of users, has maybe seen a couple spins. They're beyond an Arduino and a 3D printed enclosure. They're significantly before DFM. So all of that kind of naughty space in the middle is where Highway 1 operates. So we'll kind of assess what their greatest risks are when they come into the program, and we'll do different prototyping cycles to also mitigate those risks. Like we don't believe in de-risking, we believe in mitigating risk because there's only so much uncertainty that you can eliminate. So one thing that we do in terms of product development is go from what is commonly known as an MVP to a fundable prototype. And a fundable prototype might be not necessarily on your critical path, it might be slightly off your critical path, but a fundable prototype also has your story that's been prototyped. It has a pitch that's been prototyped. You have kind of done all the diligence around developing a narrative and developing a whole ecosystem around your product, including handling the technical aspects of it. And so we consider the product development to kind of encompass all of those things and not just dwelling on the technical side. I mean, that being said, our team will focus on firmware risk, EE risk, ME risk, ID risk along the way. Each of those will have like one or two of the highest ranking risks mitigated along the course of the program.
Got it.
Yeah, I'd echo that. A lot of what we do is, define the problem first, like what are our requirements, what are we going after, and then from there seeing what is the highest risk part, right? Like what is the functionality that you don't know if it's going to work, and prototype that first. It's the idea that you fail often, but you fail really fast, and that's okay. I would say is really important to accept failure and be able to move forward from that. So prototyping really allows you to see where you're going to fail and push forward from there.
And so if it's all either around risk mitigation, in your case, failing quickly, is speed the most important thing for you during that prototyping? Or how do you think about mitigating that risk?
Yeah. Speed is really important just because you don't want to be working on the wrong thing for too long. Yeah. But you need to know the resolution of the prototype you're making, right? You need to understand what's critical. Like, is it critical that it looks a certain way? Sometimes it is, but often it's not. So, when you design mechanisms, you need to make sure the mechanism works. And oftentimes, we're getting into materials now, but you need to make sure you're using the right material. You need to make sure you have the right tolerances, because those are the things that make mechanisms fail.
Can I add?
Yeah, please.
Yeah.
So I would call it speed, but I'd also call it energy, right? You want to input the least amount of energy into the system to get the maximum amount of result out of the system. So figuring out how low of a resolution can you make something in order to get a learning. Time, is kind of a function of energy, but it's also a function of a number of other things. So you really want to focus on like what's the energetics in and what's the learnings out, And that's how we do a lot of our focusing in terms of what prototype to make when, is thinking about it in terms of an energetic basis.
Does that energy resonate with you, Scott, or as you guys move through it?
Yeah, absolutely. It's not just about speed. While that's very important, I think there's a strategy piece behind all of this that's of the utmost importance. And I think the way it was just phrased is definitely our approach as well. We look at these different risks or the different questions we have on the table that we're trying to answer with prototypes, and it really comes down to what's the quickest way to isolate those variables and build a well thought out prototype that we know when we construct this prototype and test it in the way that we intend to test it, we're going to answer that question. So that's a level of strategy that sits above all else.
So I think for me, you guys will have to forgive me, but I'm the engineer, so I want like the equation, right? So when we talk about energy or how much input's going in or out, is there a equation that you guys follow when you're like, okay, I'm in a whiteboard stage and the next things I'm gonna do is foam core, and it's always foam core. And then I move from foam core to 3D printing to high res maybe. Like, is there an equation, Scott, you got the mic, but is there an equation you guys follow in there? Or is it really depends on the product itself?
As a consultant, there definitely is not an equation. There's a set of prototyping strategies, but every project that comes in the door is a wildly different domain. You compare a consumer electronics device that's going up on Kickstarter to a medical device or a robotic system in some B2B application. All of these things have very different challenges, both regulatory and in terms of how they're sold, how they're marketed, the feature sets, and what standards they're held to in production. So I think you can't write it out as an equation. Maybe if you find yourself working in a company where you're iterating on the same exact type of product, your team might be able to boil it down to a very step 1, 2, 3 kind of process. But for us, and I think for a lot of hardware companies in the early phases of product development, you're bouncing between CNC prototypes, 3D printed prototypes, looks like models, works like models. These are all kind of the different prototyping strategies just become tools in your tool chest, just like the manufacturing processes themselves.
Right, you must have an equation. You got 20 people
every
year, 20 groups. A plus B equals?
A plus B equals, so what we like to say is it takes 7 seconds to do a whiteboard sketch, it takes 7 minutes to cut something out of foam core, it takes 7 hours to 3D print or CNC something. It takes 7 days to do a looks like prototype. It takes 7 weeks to do an integrated prototype. It takes 7 months, and that's obviously very generous to do a manufacturing cycle. So the question is, where do you want to make a lot of mistakes? You want to make a lot of mistakes when it takes 7-second whiteboard sketches, because you can do 5,000 whiteboard sketches in the time it takes to do an integrated looks like prototype. So how many of those sketches can you do in order to learn something? So it's it's a rough rule, but it's something that we really try to preach. And even people who come into the program who are pretty far along, we often will find a lot of success in bringing them back to foam core. There's a ton you can learn from getting your hands dirty with an X-Acto knife, some hot glue, and foam core to just test an assumption and test it really quickly. So you get people who've been engineers for 20 years, who have worked at large companies, who are used to very different kind of development timelines, and you get them back with foam core and they realize that they can actually move a lot quicker.
That was pretty close to an equation, but you work on mechanisms every day, right? So it is an equation, yeah?
No, not at all. Yeah, exactly what you guys are saying. Like, it really depends on what you're looking for. And also development phase, right? Like, if you're an early stage startup, it might make a lot of sense to do a lot of whiteboarding. If you have a MVP and you're trying to iterate and make sure that you've chosen the right design, you work on those specific things. Yep. The scale of your prototype, I think, matters a lot, not just the resolution. Like, pick out the critical things and then work on those.
I think that's a really good point, which I think leads me to the next question, which, okay, so there's no real equation necessarily, but if we let's just pick 2 technologies, that's why we're here today. Additive, which is 3D printing, CNC, which is subtractive then. Do you think about it in terms of a process that you're going after, or it's, hey, I'm in that phase, I'm 7 seconds, that I've spent on the whiteboard, I'm in my 7 hours now, so I leverage 3D printing, or is it cyclical, or is it a process?
It really depends on what you're doing, right? So if you have this idea and it has all these weird axes and it's not easy to machine, and you can't distill it into, 2-part flips or 3-part flips. Yep. You go and 3D print it, And
Can you explain flips just for other folks?
yes. So usually in a CNC, it's 3-axis. So your machining tool comes up from the top and does whatever path. And then every time you have a different side of the part that has holes or a pocket cut out of it, you need to do a part flip.
Cool.
So it kind of is a way to talk about the complexity of a part, and also how expensive a part is going to be. So oftentimes it's like, oh, you need to like cut down on your part flips. This is like, we don't have the money, we want to go fast, right? So it really depends on the complexity of the thing you're making and what's important about it.
How about for you, Rafi?
Yeah, so for us at Highway 1, we leverage technology more as an educational tool than anything else. So it's what are we going to get out of it and what is a startup going to learn through that process? So if we're going to make a bunch of something and there's going to be serial iteration, we'll probably use 3D printing, go through an additive process because they're really learning through the doing that goes into that. But if we want them to learn about the specific manufacturing process of CNC, or we're making a soft tool to do some kind of prototype injection molding processes, we're going to go to that process because it simulates what they're actually going to see in the real world. So the more we can educate them through the tools is our kind of prime motivation for using those. We also, almost anyone can run a 3D printer, which is what we have at Highway 1. I'm the only one who can run the CNC, and there's only one of me at Highway 1. So there's 30 people who know how to run a 3D printer, and there's one of me. So it's also a time equation in that regard as well.
We are constantly bouncing between CNC machining and 3D printing and any number of other manufacturing methodologies. And I think, again, it all starts with the question. So if we are at prototype number 3, some critical function that we're trying to evaluate, it really comes down to what question are we trying to answer? What are we trying to learn? And if that means it's some ergonomic factor, or we're placing a tablet or a 7-inch display at a landscape versus portrait, what are the ergonomic considerations there? Then, hey, let's do it with foam core. Again, whatever's quickest, but get us to that accurate answer. If, on the other hand, we're trying to evaluate the performance of some snap fits or some mechanism or something along those lines where the tolerance has to be super tightly controlled and the material spec has to match an injection molded plastic or something along those lines, you might find yourself running into limitations with material options for 3D printing or CNC machining, and that might steer you in one direction or another. So again, it all starts with the question and trying to be strategic in what we're hoping to learn from whatever it is we're building, and then we will evaluate any number of processes. And that goes beyond the CNC and 3D printing concepts that we're discussing this evening. It's vacuum forming, it's sheet metal, it's extrusions, both plastic and aluminum, any number of processes.
I think something you talked about, Scott, was the concept of a toolbox as an engineer that you're constantly pulling for your top shelf, bottom shelf. So the stuff you use all the time is always sitting in the top shelf. Something we do a lot here is trying to help people pick either the best material or the best technology for the stage that they're at. So to help folks get some tangible things even to take home with them maybe, what is the, in your top drawer of that toolbox, like the material you use the most, maybe by process, so for 3D printing or CNC? If you have to pick 2, you can, but what's in that top drawer of your toolbox?
It's a good question. I've been kind of enamored with SLA 3D printing recently. So yeah, I think there's things like it's the Acura Extreme White SLA 3D print material. It's marketed as something that's kind of a stand-in for ABS. The specs are close enough, but it is a very durable material. You can do snap fits. The resolution is insane if you pay for the very high resolution. And it's something that can be painted and treated and things like that. So there's a lot of flexibility in terms of what are we building and why? Is it looks like model, so then the surface finish is really important, or are we evaluating snap fits? So then the flexibility and the mechanical properties, we're going to take a hard look at those, and it's oftentimes a good fit for an injection molded plastic down the road. I'm a huge fan of those materials. It's a really cool manufacturing process.
How about machining?
For machining, we oftentimes find ourselves machining parts because we're mocking up something that's supposed to be made of aluminum down the road. So maybe it's an extrusion, or what's envisioned to be an extrusion, or a die-cast part, or something along those lines. So we've been doing a lot of parts in aluminum, some parts in stainless steel. We've recently been doing some components that have very, very tight and specific thermal requirements in terms of their conduction properties. So in that case, that kind of rules out plastics. We needed high thermal conductivity. I'd make it out of copper if I could, and we kind of settled on aluminum. And then of course you can look at any number of different aluminum alloys. Yeah, and that would of course be influenced by, again, where is this part going down the road? Is it going to be an extrusion? Is it going to be a sheet metal part? And that may influence your alloy selection.
Do you guys you want to share maybe your top toolbox, Rafi?
Yeah, top toolbox. I really like slamming things out with an FDM printer, and I really like using foam. So it's hard to separate the two. Like foam to work really, really quickly, move through a lot of ideas really fast. You can be gestural with it, you can machine it, so it's less of a tool than a material, but there's just a lot you can learn either quickly or slowly with that, and then just slamming parts out with the FDM printer is just, it's easy to learn, it's easy to learn a lot quickly. Yeah.
I'll second that. We have an FDM printer in house. It's the one way that we use Fictiv kind of in both directions, both as a customer and a vendor. It's a U-print that has been running since day one we started our company.
Yeah,
Greg's baby.
We have a
Running right now.
Yeah, we have a U-print that when the cohort is going, we'll often be running like 22 hours a day for 4 months. Like
It's awesome.
just nonstop, and they don't break, and there's no problems.
So I work with food, and we do mostly like less looks like models, more mechanism design, like prototyping type things. So a lot of our stuff, since it touches food, is stainless steel. But when we're prototyping, you do not want to machine stainless steel. It's hard to work with. Vendors don't like it. So we use aluminum oftentimes. It's just a good analogy to what you're going to get in real life.
Got it. So like a 6061 for aluminum.
Perfect.
Got it. Are you doing 316 for stainless, or?
It depends.
It depends on
yeah.
it.
Yeah.
This is where it starts to get nitty gritty, where everyone's like, what? You're starting to throw numbers at me. I still remember the first time I'm like, a junior in college, and I'm going to Proto Labs, and I'm looking at First Cut, and I hit that drop down menu the first time. Yeah. It's like, there's 50 different options. I'm like, what's the difference between all these alloys?
304, 350,
all over the place. So we spend a lot of time helping folks there as well. So I got some specific questions, I think, for you. I'll riff off this one for you, Abby. How do you educate yourself? If you're in the works, always doing mechanisms every day, how have you thought about educating yourself with new technologies and materials over time? Is that a constant challenge, or is there a place or a resource that you use a lot? Maybe it's a textbook still?
Yeah, actually, surprisingly, I use textbooks a lot. Something in more recent years, I've grown into doing more mechanism design. I think early on in my career, I was doing a lot of fixturing, a lot of like static tools. And now that I'm doing more mechanism, like surface mating, like how materials interact is hugely important. You get all these failure modes of like, galling, or are you spalling, or,
Yep.
And so learning the intricacies of picking the right material is super important.
Yeah. But textbooks are still your best resource?
Oh yeah.
Is there a favorite one you can still think?
Well, and Google.
Oh, and Google.
And Google.
I
like, what else? What's
Google?
better?
I don't know.
I'll show you later, it's
Okay,
fine.
thanks.
All right. Yeah.
Cool. How about for you guys? Is there a resource you love or that you share?
We have the startups. So, we see 20 teams a year. We've done 67 teams. They're always doing diligence on the best resource. A lot of resources are local. We also have our overseas resources as well. Our sister company, Lime Lab, and PCH, so there's kind of a constant flow of like new ideas, new technologies, new vendors coming through. Our network is really huge, and we use everybody, so there's a ton of learning that just kind of comes through without having to look for it at all, which is very convenient.
I think I'll riff off that for you. What is, since you see these patterns, I would imagine happen over time, if you could like wave your magic wand and each new batch like knew one thing about hardware development, is there like a core lesson that you just preach every day? It's like boot camp that kids walk in and you're like, hey, you know this.
Yeah, I mean, it's an oft-repeated maxim, but don't let perfect be the enemy of good, right? Like, learn as much as you can, get your thing, whatever it is, in front of people who are going to use it and have that experience. Know that you're making the right thing with the right features, with none of the wrong features that people want. Kind of really all too often people go into the hardware development being really excited about an idea that they're the only person in the world that it applies to, but they're convinced that it has the potential to be a $100 billion company, or they're just working forward on an idea that does have users in market, but they're kind of validating assumptions in terms of how they go along the development process. And it's hard to be humble because you're so enveloped in the process and you kind of think you know more than you do, but it's often very kind of internal, the hardware development process. And for people to really look outside themselves and not validate assumptions along the development process is something that I wish people could know in the very beginning of what they're making. I think there'd be more better stuff in the world.
It's something.
Yeah.
A lesson that I wish we could impart on many of our clients. There are a lot of types of products, and there's a phase in product development at that very early bleeding edge of things when you're just getting started, where statistics don't matter. So you're trying to evaluate a product concept. It doesn't mean that okay, so it's sunk in that you need to test your assumptions, test your prototypes, but it does not mean that the next step is that we're going to go build 200 of something, because that's our n equals, we want that sample size. That is very, very, very hard to do. There are certain quantities that for a certain type of product it's downright impossible to build that n equals number cost effectively. And you will get so hung up trying to pull that off and trying to make it cost effective and trying to prepare yourself to piece together 200 prototypes or 50 prototypes or 100 prototypes that you will skip the step of just building the foam core prototype or just doing the FDM print, putting it in front of 3 users, the same prototype, go from one house to the other house to the next house. You've done it all with one set of parts, and you've internalized their feedback to the point where you can move on to the next question and challenge the next assumption and build the next iteration. And you've saved so much time and so much money and so many headaches from trying to build that n equals number that's painfully large.
Can I add to that? So I think an object lesson that we had that kind of resonates with that statement is that a team came to us and they had spent a ton of time building a looks-like model. People really liked the looks like model, but it didn't do anything. And they had given it to a lot of people, and everyone was like, this is awesome. We like what you tell us what it's going to do, but we have no experience of it. The thing that actually worked was the size of a suitcase. And they didn't want to give it to anybody because they were worried that they'd be turned off by the size of a suitcase. And the point is that if you're delivering the awesome, a suitcase doesn't matter. People will lug around a suitcase if the experience is good enough, but people aren't going to buy your thing just because they like the way it looks, but have no idea what the experience of it is. So kind of managing that whole cycle and just getting that experience, whatever it might be, in front of someone as soon as possible. So you can probably be wrong a few times and then finally land on what the right experience is. One of my mentors said that you should be embarrassed 75% of the time when you're developing hardware. And I think that really resonates as a lesson. Make the wrong thing, be embarrassed about what you show people, learn a lot.
Cool, I think that's good. Scott, I had a question for you that you were, I think you're in a unique position compared to the other panels here where Abby, you're building stuff for yourself generally in there. Rafi, you're trying to teach and make sure that people build better products. Scott, is there a challenge for you of trying to describe these technologies to clients, of telling the difference of, hey, yeah, you can machine this out of aluminum or you can do it out of stainless steel. This one costs $10,000, this one costs $1,000, but I promise you the strength on aluminum isn't going to last. How do you educate and overcome that barrier?
Yeah, it's a good question. I think the key to it all as a team of consultants is the name of the game is all about transparency. So there are these decisions happening, and I'm an engineer or employ a bunch of engineers. It's all too easy to kind of take some product specs, as vague as they might be, from a client and just go heads down into the books and start designing, and all of this is happening behind closed doors. You're making decisions left and right. 2 weeks later you meet with a client and it's not what they were expecting, or it's just not in line with what they were thinking, and they don't understand the decisions that you've made. So for us, when we're bouncing between manufacturing processes or proposing different prototypes to build and then going out and making them, it really comes down to this level of transparency and being clear on why we're going in this direction, what are the options that we've evaluated, and collectively deciding okay, here are the trade-offs, what makes the most sense? Again, reflecting on what's the question we're trying to answer. If we build it out of FDM 3D printed parts, if we build it out of aluminum, for a given object, we're going to learn very different things, or a given prototype, you're going to learn very different things. What you're able to test and evaluate with that prototype in hand is going to be wildly different. So for us, being super clear about the trade-offs, both in time and price, and what we expect to learn from a certain prototype, and keeping that upfront very clear about that, and doing all of that in a collaborative fashion, that's kind of the key to our process.
Yeah, I think the transparency is really key. I mean, in hardware, one of the most challenging things is that sticker price, or that shock that you first get. You get a part that's 3 flips, right? And you're like, that's $1,000 for one of those. And I'm like, $1,000 is pretty cheap to like build that thing. And they're like, oh, it's the first time. They're like, I can go to Best Buy and buy that for $500 or $100. So I think the transparency is key. You guys have been an awesome audience. I wanted to see if there's any questions in the audience for this for the panel. This up here? Yeah, please.
I have a question for Rafi and Scott. I think I'm curious, when people come to you and they have something that is pretty far developed, and you need to walk them back to, say, a whiteboard or some earlier stage, it seems like you have to make a pretty compelling point to do that. I'm wondering, what do you tell either a cohort or a customer to step them back?
It happens. We've definitely seen that, and it is challenging. And I think they may have found themselves in that position because they were surveying people and getting very superficial answers about what a customer, in your survey question, what they want or what they desire, what they're going to purchase. And so for us, if we can deconstruct that concept and start probing and testing with prototypes that are in front of an actual customer, and we're being very strategic about that process, we can start to get higher quality customer feedback into the conversation that we are having internally back and forth with our client, and hopefully they can kind of start to see the light and see what needs to change. That's certainly one thing that comes to mind. Another option, or another thing that happens, is that there's a tremendous amount of feature creep. That happens all the time with our clients. And so that, I think, gets back to that point about transparency. If we can do our homework and really put some numbers to features in terms of development time, development costs, manufacturing complexity, what might happen to your yield rate or the BOM cost or any of those things, start staring at some hard numbers, and it helps people make decisions. So again, getting back to that transparency point.
Yeah, so I have 2 answers to that. One is for people who are in the program, and for people who are in the program, we'll really question what the motivation is to be pushing forward with the process they're pushing forward with, and just try to kind of convince them that it's acceptable to take a step back and try to mitigate risk at these low resolutions, because they can move quickly, and a lot of people either haven't thought about it or just haven't been educated in that way. And actually, it's usually fairly easy to get people to test things at a low resolution once they're in the program. When people are applying to be in the program, I'm far less nice about that process, and mostly I try to get them to say that they are asking for me to give them money for something that they think is the right answer. And when you say that, it sounds pretty stupid, because they need to be saying I know this is the right answer, instead of saying I made this crazy thing. It's well, here's 3 ways to prototype this, and they're all on a whiteboard, or they're all with foam core. How come you didn't do that? And then it'll usually send them back to the drawing board.
Great question, thanks. Anyone else?
Abby, you have totally avoided the question of your favorite textbook. I want to hear that.
Shigley's mechanical design book is the Bible. Also, Machiner's Handbook is necessary.
If I could have a Control F on the Machinist Handbook rather than having to flip through. I know there's a digital copy, but I don't have one.
Oh yeah, I have a paper copy too. I didn't even know there's a digital one, so.
You should invest in it. Yeah, Scott.
It was related to the textbook question. We were talking a little bit about tracking down material specs, things like that. If you can Google your way to a data sheet from the company that makes the material, that's the best case scenario. So if you look at stainless steels, food grade steels, there's AK steel or something like that. If you start searching 316 or 17.4 or any of these stainless steels, you're probably going to end up on one of their data sheets, and they're really well produced, and I would trust those numbers, and they have really good secondary pieces of information about what you can do in terms of heat treating certain materials and things like that. So I think that's a treasure trove of information if you can find your way onto the right spec sheet.
That's a good one. Yeah, Sylvia.
I have a question. It's more for Rafi, because I know you guys have this awesome lab over at PCH, filled with like awesome machines. So you mentioned that, like at any given time, like 30 people know how to run a 3D printer, only one of you know how to run a CNC machine. Are there people who come to you and be like, I want to learn how to CNC? Do you see people being interested in learning about CNC machining?
We do occasionally get people who are interested in really learning how to CNC themselves, and I can give them some resources, but it's unlikely that we're going to train them up on the machine. It would just be kind of a resource suck in terms of our energy, like to spend a couple days and bringing someone up, like 8-hour, 10-hour days or whatever it is to get someone running on a machine is a lot of time for one person on one team doing one problem. So it comes back to that like energetic input versus learning output. It would be a great experience for them, but it's not worth the energy. Yeah.
Do you have any resources for people who want to learn more about CNC machining? Like, where would they send? Where would you send them to if they want to?
Send them to me.
I'll send them to him. And I suppose Tech Shop, but we've not really had someone be that dedicated to like going to external resources to learn how to machine.
Thank you.
I have two things that I can add to that, or I'd like to add to that. One, there are some amazing YouTube videos. We were talking about Tormach machines earlier. There's some incredible YouTube channels on how to operate that equipment. I think that's what Highway 1 has as well. So some really, really thorough tutorials and walkthroughs of how different parts are made and the methodology behind it. So that's been, I find myself watching those sometimes even though we don't have a Tormach. It's just interesting content. Maybe I'm a crazy nerd.
No, I'm there too.
All right. Two, I think there's a benefit to working with a company like Fictiv. So there's a kind of a process of trial and error when you're designing FDM parts or polyjet parts or CNC aluminum parts. If you're a fledgling engineer or designer or entrepreneur trying to build a hardware product, you will kind of learn some of these things through trial and error. And the advantage of working with Fictiv versus some of their competition is that there's a much better dialogue between you and an engineer at Fictiv, not just a salesperson, an engineer at Fictiv, and then the next step to their vendors. Some of the guys in the front row here who are making the parts know way more about what's going on, like how this piece is set up, what are the cost drivers, what's actually going on when like tool meets metal on the end of this mill. And that information can get passed back to the Fictiv engineers, back to you, you get feedback, you end up with much higher quality parts. So you make some mistakes early on, and this is kind of an iterative cycle in and of itself, and your engineering skills, your design skills get better and better with time, be it 3D printing or CNC machining. So huge advantage of working with the engineers here at Fictiv, that they can help you kind of deconstruct what's going on with your parts and how to make them higher quality and how to make them less expensive.
Oh, I couldn't give a better plug for myself. And I think it's great. I mean, it's what we really try and do here. It's part of the community events that we throw, all of this, where you come and learn from experts in there. You meet other experts in the fields that are all here. But part of what we're trying to do is help these engineers and advisors be more efficient in their day and their prototyping all the time. But it's also giving time back to the vendors and the machinists that are producing it. That yes, they know the way that the chip is flying off of there, but that's a very valuable time. And so we try to act in the middle to answer those first line questions, and we have access to some of the best machinists in the world. So our belief is when you couple the automation that we've built from a platform side with the human elements, be it the engineers, the machinists, or the people building products every day, that's where the whole community wins. And that's what these events are about. So with that, I want to thank all of these guys for coming today. Maybe a quick round of applause. And just the take-homes, again, because on the engineers, you guys walk out, the things that stood out to me was when you're prototyping and developing hardware, it's all about risk mitigation, right? We talked a lot about that, of defining what your risks are and how do you mitigate against them, Rafi, I love the sevens. I'm going to use that and steal it from you. But 7 seconds on a whiteboard, 7 minutes on foam core, 7 hours on a 3D printer or CNC machine, or do you want to spend 7 weeks cutting an injection molding tool? That power of 7 was pretty key. And Abby, you're going to have to show me all about Google and this magical textbooks as well. So thanks, guys. Please stay around. There's lots of food and beer. Make sure you guys eat it. Take some home. If you are driving, please don't drink. And thanks again for coming. Cheers. Thanks, guys.
Cool.
Yeah, it's fun.